we will be so this is the design process we will be using for achieving the sustainable design. So we will be starting at the climate level. So we need to understand the climate and wind pattern of the site. Once we're done about it, then it goes to the site level of buildings. What form of building can be most appropriate for the site or the locality? Is there any orientation change gives the benefit or not? Then we will be going at the sun path and shadow level analysis. So we can able to understand the shadow pattern of the analysis of the building in the analysis, so that we can able to change the urban detail and effect. Then followed by we will be designing the each facades with the help of solar insulation. Then the most importantly daylight and glare analysis and associated shading analysis. Then comes the internal ventilation analysis, thermal comfort and envelope analysis. So once after we done all the passive analysis, we need to do the active design part. So today's topic is we will be covering all the passive designs. So the first and foremost analysis is climate and wind analysis. So this is the fundamental analysis for whatever the project you take. This is the fundamental analysis. We will be discussing about the basic parameters like what is the temperature range, what are the maximum humidity, what are the wind patterns, like what was the prevailing wind, what would be the leeward side, so that we can able to zone the building. So the temperature will help us to design the specific climate related strategies, like certain climate would be suitable for cross ventilation, certain strategies like having the thromb wall would be suitable for different climates. So those strategies, climate oriented strategies, would be sorted out at the climate level. So the next one is sun path and shadow range analysis. So okay, Dheeraj, is my audio clear? Hello.
There's a slight disturbance, Bogan. I think you can check for the internet. You can proceed now, not a problem.
Okay,
there's a small flicker in your audio.
Okay.
So our audience might not connect for the few points.
Okay.
Yeah. Go ahead, Bogan. No problem.
Oh, sure. So we are talking about the sun path and shadow range analysis. So the sun path analysis is like it's one of the analysis which when an architect would start learning at the schooling level itself. At school, it's like we will be learned about the sun path analysis, but we will not be doing the detailed analysis. We will not be solving the purpose of the analysis actually. So we will be drawing that the sun will be traveling from the east to west, but the benefits are not captured at the analysis. So here, what we'll be doing is we will be understanding the shadow cast by the sun. So we will be taking at the different time periods. So at different time periods, like we call this a winter solstice, summer solstice, and equinox. These are the three different timing levels. So we can able to understand it, whatever the shadow has been casted, and what are the benefits. So the benefits would be like mitigating the urban heat island effects and utilizing the neighbor buildings shadow. So this will be the most popular benefit we get from the sun path. So this is a case study. The building is actually an academic block of built in the IIT Rohpur. So here, when we designed it, engineer and architect designed it, we have actually suggested a little modifications like increasing the shade of the building to an appropriate level, so that the internal courtyard will get the comfort. So that the shaded courtyard actually created a passive cooling effect around the building. So when you're able to get the passive cooling around the building, that is actually benefiting your own building by reducing the cooling load of the building. So the next one is once after we understood about the climate and the wind pattern of the building, then we will be going into the mass inform and orientation analysis. So when an architect starts to design a building, the initial stage would be getting the concept. At the concept level, he will be designing with lots and lots of the mass and different forms and different orientations of the same building. So when we design it, we need to freeze it a certain space to be a finalized model. So because an initial idea would be quite more boundless, you would say. So like, you can able to design it at a different forms and all. So this is a typical project. One of our project, like it is a corporate office for a bank, which an architect designed it with two different formings, massing. So initially, you want to design it at the circular level, circular building. Then client wants to do it with a rectangular building. So that they designed both the different forms of the building, and they came to us with a sustainable perspective on it. So when we done the solar radiation analysis into the building, we found it out that the circular building actually receives lesser radiation than the rectangular building. So we can able to quantify it. So with the quantification, we can able to convince the client that the circular building got more benefit than the rectangular building. So this is the same academic block which I told you at the IIT Roorkee. So what happened with this design is initially when an architect designed it, it was at the perfect 0 degree. The central block which I'm talking right now, showing right now is the central block. It's a 0 degree with a lot of analysis. It's like here we got a lot of limitations, like we cannot able to rotate building completely. So our maximum restriction was around some 15 degree, whether it's a clockwise or anti-clockwise. So we did a simulation with tilting as minimum as 5 degree clockwise, 10 degree clockwise, and the same with the anti-clockwise. When we done the different analysis, we came to know the maximum benefit. We got it at the 15 degree anti-clockwise. So with the help of, we can able to understand it. This changing the orientation would be require a zero capital, but the benefit would be an unlimited. So achieving some 10 megawatt hour a year would be achieved throughout the building's lifetime. So the benefits are like because of changing the orientation of the central block, you can able to attain both aesthetically and sustainability unique building. So with the help of this, we will be achieving around some 2070 ton-hour of cooling energy consumption over a year, which is equivalent to 6 tons of CO2 emission. So the next one is solar insulation. When we can able to finalize the ideal mass of the building and finalize the orientation of the building, this is running next step to the analysis. Like we will be finding out a crucial facade of the analysis. Since we have a lot of facades, when we are able to finalize the orientation, each facades will be analyzed with the solar radiations, so that we will be finding out which are all facades are the crucial facades. Like most buildings will have west facade as the crucial facade because of the radiation. So it clearly tells us like having a large window wall ratio at the west facade is not recommended. So typically at the north would be the beneficial side, like having the least radiation, so that we will be designing more windows at the north facade. So this will be changing case to case and the building to building, just because of the neighbor buildings, the effects will be changed differently. So this also not only helps us in designing the window wall ratio, this helps us to design at the planning level. Because when we get the huge radiation at the west facade, we will be designing some service flows, service areas like toilets, staircases at the west facade, so that the radiation ingress into the conditioned space can be cut down at the initial stage itself, so that those staircases will act as the thermal buffer. So this is the case study building. So this is the case study of the group housing which we done it at the Hyderabad. So this is one of the premier housing project of around some 300 plus housing individual villas at the place. So when they started to design it, as everybody got it, like they want to design it as a sustainable building. So they initially proposed it to be a double wall and the DGU glass window for all the facades. So the same architect has approached us and like after that we done the simulation and we found it out that the double wall and the DGU window is not actually required for the non-crucial facades, because the crucial facades are south and east in this case, because it's like the west facade was mostly shaded by the neighbor building, whereas the east and the south facades are not shaded. So these two facades actually required the double wall and the DGU glazing. So we requested them, it's like the energy savings between double wall with all the facades versus the double wall with east and south facade, it's nearly the same. So we recommended them to reduce it facade. So the benefits are like we are able to achieve some 10% of cooling load requirement at the capex level. The initial level we have had a savings on it. So the next one is about the daylight analysis. So this is one of the this has been one of the important element in architecture for a longer period. It's like in the olden days, the space, the windows opening and everything has been designed based on achieving a proper light in the space. So right now what we do is we got the tool which helps us to measure, which helps us to quantify the amount of daylight we get it at the space. So with the help of these tools, we can able to measure the exact amount of daylight which is received inside the buildings, so that we can able to change it a bit, so that around the building we can able to achieve a comfortable quality light. So the daylight is important. Since I told you daylight is one of the important element in the building, it is just because till now we have seen certain analysis. Those analysis will get the benefit in the energy savings, whereas the daylight has got a benefit like it also helps us in the energy saving. Also, it has got a lot of health benefits, because the buildings without achieving a lot of daylight would create a syndrome called a sick building syndrome. So the sick building syndrome has got a lot of different parameters to achieve, to happen in. The daylight has got a major weightage in it. So what happens with the daylight syndrome, sick building syndrome is, this will hinder the productivity of the people. If it is in school, it's like the concentration of the people have been undisturbed. Whereas it is in corporate office or in any ideal office, the productivity of the people have been hindered. So that is why in the modern buildings they are demanding to have a well daylighted spaces. So here we can able to the energy consumption, reducing the energy consumption with the help of a lot of sensors are there. So we can able to achieve the savings with the help of different sensors. So this is the example of IIT Ropur. Here we have done the analysis for each rooms to understand it how the daylight ventilation is happening at the different levels of the room. Specific the space, we be also getting a glare, so which is a direct radiation entering into the space, which will try to increase the heat into the space. And also what will happen is, when we get too much of glare into the space, we will put the curtain in, and we will be cutting down all the good quality of light entering the space. So designing the fenestration shade would be an important element in designing a building. So these are different options we have tried it for one of our building, the group residence. So this is an east facade window. what happened is like we had tried to design it with the conventional type, which was designed by an architect. So I can able to show you the drawing clearly. So when we design the box shade, so this is a stereographic diagram, a representation of a window, how it is exposed and how it is shaded actually. So the gray shaded portions are shaded, whereas the white color are exposed times, and the colored one are shaded actually just because of the shade. So since it is an east facing window, the morning hours are actually exposed, whereas the evening hours are being shaded with the help of the building itself. It will achieve the self shade. So with the help of the conventional shade, we can able to understand it around some 2 hour a day for throughout a year. We will be achieving the shade. Whereas we have got a lot of hours which will be exposed. So we have done a simulation with horizontal louvers, with the louver width of 300 mm and the spacing of 300 mm. We have done a simulation with different numbers and different tilting and all. We found it out actually horizontal louver has got a benefit like less than an hour. It's like half an hour to 45 minutes it's been exposed throughout a year. Then we done the same simulation with the vertical louvers which is tilted to 30 degree. Because we done the simulation with the vertical louvers, which is not actually much benefit. Most of the hours are exposed. So we done it with the 30 degree tilted at the vertical louver. So what happens like it is being shaded at most of the hours at different periods like June, May, April till September it is being shaded. Whereas it's like at the different timings and all, we will be exposed to it at the different timing of the year. So based on this analysis which is carried out with the different shading elements, we found it out the horizontal louver actually performed better and more feasible for the project with balancing the base design. So we are able to implement the horizontal louver at the specific windows. Typically, this is done for the east facade window. Typically, all other facades windows will be carried out with the same type of analysis to find out an appropriate, perfect shading. Because a perfect shade should cut down the glare, and it's like it should not avoid the good daylight entering into the space. So the next one is envelope performance. So when we start talking about this sustainable building, the first and foremost element comes into mind is the envelope materials. So to achieve the sustainable building, we would be directly going into a buying of sustainable materials like having the building with the adobe bricks, having a bamboo as an element of a building. So this is a common perspective that this will make the building more sustainable. But whereas what we will be doing here is we will be analyzing the heating load gained inside the building with the help of different materials, because each material will perform differently. A material like concrete blocks and the brick. Concrete wall and the brick wall, the heat gain and the heat storing capacities are two huge difference. So we will be analyzing with the different types of walls, the wall inclusive of and double wall, sometimes the common wall called the rat trap wall. So we will be analyzing with the different walls and find it out. And find whichever is more appropriate for the building. Okay. So the next analysis is thermal comfort. Here under the thermal comfort, this is one of the important and a large topic to discuss. Here what we'll be doing is what there are six parameters to understand about the thermal comfort. The parameters like the air temperature, the radiant temperature, the humidity of the space, the air velocity of the space. Then there are two personal parameters to understand the thermal comfort. Those are the metabolic activity done by the occupant and the clothing, the clothing insulation which the occupant is wearing. Because it's like the thermal comfort for the office building and the gym cannot be the same, because the metabolic activity happened at the gym is completely different than the person occupied at the office space. Because it's like in the gym, the person itself will be generating lot of heat from his body, so that need to be accounted at the cooling load. So based on that, we can able to understand it. It's like these six parameters are there to achieve the thermal comfort. Even by reducing a single parameter, we can able to achieve a little thermal comfort. So we can able to do it like the air temperature, reducing the air temperature with the help of different parameters. Still, whatever we have seen it, that actually helps us to reduce the heat load ingress into the building. And certain parameters like changing the envelope material, reducing the window wall ratio helps us to reduce the radiant temperature of the building. By adding some adding and personalized fan to each person would get the thermal comfort also. So this has got a lot of different strategies to achieve the thermal comfort. So this is the case study. This is one of the forging shop. To give you the perspective, like initially the forging shop was designed. You know, the forging shops are the place where they will be melting the iron or the metals to produce some different materials. So since the heat generation into the inside the building was huge, the normal air temperature was measured at around some 51 degrees Celsius at the center of the plant. So with a lot of strategies discussed about it, the first and foremost strategy which everybody would be knowing is incorporating stack ventilation. So we proposed a stack ventilation. We proposed a ridge ventilator at the top of the plant that helps us to increase the airflow ventilation in the building. Then we added a insulated envelope in the building that helps to reduce the heat ingress into the building. Then, since it is a forging shop, cooling down the whole space is not possible because it is not viable to reduce the whole space to get into comfort. So we achieved it around some 35 to 38 degrees Celsius at the from 51 degrees Celsius. Then wherever it is possible, two-stage evaporative cooling can be proposed so that an employee is independent to use it, the two-stage evaporative cooling, which is more efficient than having the pedestrian fan at the industries. So the net zero energy building. So to give you the perspective, we have gone through the different passive design strategies. We could tell it is in different approaches to achieve the net zero building. So to achieve the net zero building, we would be knowing that the conventional building, whatever the energy is being consumed, if we can able to put all the renewable energy at the top of it, or get the renewable energy from outside of the building, we can able to achieve the net zero building. So with previously I told you about we will be getting the comfort. At what cost we are getting the comfort? Similarly, we can able to get the net zero building. At what cost are we getting the net zero building? So with the help of these passive designs at the site level and the building level, also there will be an active design part which will have the major weightage to get the net zero building. With help of those design strategies, we can able to achieve the net zero building at the lower cost itself. Like to give you a comparative idea, if you can able to get some 100 megawatt hour per year, So that it's like we need to propose all the 100 megawatt renewable energy at the top of it. So when we can able to reduce the required demand, the electrical demand of the building, so with the different strategies and different active strategies, we can able to reduce it to 45 or 50. We can able to reduce 50% of reduction with the rightful selection of each materials. So that the demand reduced, and rather than going for 100 kilowatt, we will be going only for the 50 kilowatt, which is more feasible to achieve the net zero. So this is one of the case study where all the passive strategies has been implemented. So this is Coca-Cola factory, Fabs Coca-Cola, done in Cambodia, where all the passive analysis been carried out. And this is the pharmaceutical factory. This is a pharmaceutical factory where we have done the different analysis like airflow, ventilation, thermal comfort, and daylight. Typically, in another manufacturing factory and model multiplex, where it now I think we are open for questions. I've tried to cover most of the passive strategies, how we can able to achieve the sustainability in the building with the help of different passive strategies.
Thank you, Mr. Mugrandan. That was a great insight towards this passive design and technologies right now in the industry and in the buildings we follow. And we have a few questions from the attendees. So take question from the Shamkat Mirashi. What software or the tools used for this analysis?
So it's like, there are a lot of softwares to undergo these simulations. What majorly has been used are Ecotech software for all the passive design strategies. Then for the active design, you can go with eQuest or Design Builder. But right now, for an architect, for the budding people, for the people who are freshly entering into the market, I would suggest to go with the Rhino and the plugin called Honeybee and Ladybug. That can be used to achieve all the passive design strategies.
Thank you. Then question from Dimika Raja. How to achieve daylight without any glare in commercial buildings?
So that would be our perspective in the daylight. Because when we get the glare into the building, what happens is the common people, when we get the glare, it will affect the workspace of the building. So what they would do is they would put a blind and they would restrict the daylight entering into the space. So the strategies used to cut down the glare is providing an appropriate shade. So when I showed you about the stereographic diagram, so there we have mentioned it. When you can able to design a perfect shade, that will help you to reduce the glare into the building without affecting the daylight. But there are actually innovative products also coming out in the market to handle the glare, like the product like dynamic glazing is there in the market, which will be changing the thickness of the glass so that the glare can be removed at the envelope level itself.
Yeah, thank you. So there's one more question from Prateek. How do we do this wind simulation or a daylight analysis? Is it based on the old weather data?
Okay. So the wind analysis, like all the temperature-based analysis, will be carried out with the help of the weather data. The weather data we get it from the IMD, Indian Meteorological Department. They will be releasing the weather data of the specific cities. For the daylight analysis, what we will be doing is it is based on the solar position. For that, mostly it doesn't require the weather data. What requires is only the latitude and longitude. So based on that, the solar positions can be derived.
All right. So, question from Manisha: does it include artificial lights and equipment simulations in a building? Is one question. And second question is also how we can get the energy performance index of the building. So, first question is actually, does it include artificial lights and equipment simulation in a building?
Yes. So till now, whatever we have covered is about the passive benefits we get it from the building. So the artificial light, the equipment simulations will be done as the energy simulation of the building, where we will be covering most of the active strategies like having different. There we will be discussing about the chiller capacity, the lighting efficiencies, and a lot will be discussed. So till now, what I've seen covered today are the passive design strategies. So the passive analysis. So this will be covered under the energy simulation and active design. We also call it as a virtual audit analysis.
And this how we can get the energy performance index of a building. The second question from Manish.
Okay. The energy performance index is a metric which can be they have created this metric to compare two different buildings. So it is actually kilowatt hour per meter square per year. That is the unit of it. So that we can able to compare two different buildings. So this is something simple called having the annual consumption dividing by the square foot of it, so that we can able to get the energy performance index. That is a simple calculation.
Question from Vipul: passive and sustainable practices should go hand in hand. Why don't we use the traditional materials for such materials? Examples such as filler slabs.
Okay. So filler slab is one of the fine technique to reduce the heat ingress into the building. Those are the traditional methods, as I said. But by implementing the filler slab at the larger scale, it's not mostly feasible. So there are a lot of techniques like adding in insulation for the commercial buildings. The filler slab would be most suitable for the commercial building. What we'll be doing is whatever the benefit, whatever the number we get it from the filler slab, we can able to get it by the different elements also. So we can able to introduce an insulation of some 50 mm at the overdeck or underdeck of the roof. We will be getting the same benefit of it. The problem is the filler slab. The material used for the filler slab is the soil, the mud. By thinking about utilizing it at the larger number, it's actually deploying the nature. So it is not recommended for the larger scale. So we can go with some insulation or the industry acceptable materials.
Okay. So, can an existing home can be converted to a passive home? I mean, there's one question from an attendee.
Okay. It depends. Whatever the analysis we have gone through it, the existing house, like the orientation, the massing, it cannot be changed. It has been freezed at the building itself. What we can able to do is most probably we can able to change the window wall ratio of it. If it is a renovation project, we can able to change the whatever possible windows. We can able to replace it with the efficient windows where we can get most advantage in the daylight and different. The envelopes can be changed at a bit. Like we can able to add insulation at the top of it. So those are the many things we can do it to existing house to convert it to the passive house. Is the questions done, or can we move on to?
Yeah, I think we have done with the questions. One second, just me check. Let me check again. Is there any questions from the team? Yeah, so that's all for the questions, I think, from the team.
Okay.
So thank you very much for the such a good presentation and giving us insights about the technologies type of passive designs. For the buildings, so that gives you the betterment of the energy efficiency in the buildings, or in terms of the better daylight and natural ventilation. Uh, Thank you once again, and
Sandeep,
with
sorry to interrupt. There are three more questions that came up.
yes, yes. Right. So, yeah. So there's a question from Mahesh. Can we consider the analysis of duct insulation thickness, conductivity, and leakage for optimization of HVAC operational cost, OPEX cost, basically?
So the question is like, the insulation, the ducts insulation, this would be mostly covered at the energy level, at the active design part. So this is not mostly covered at the passive stage of the building, which requires, lot of which requires a lot of analysis at the active design part, which will be inclusive in the selection of the chiller, the selection of the refrigerant used in it. So it has got a lot of different parameters to consider the insulation thickness and duct insulation.
Right. Thank you. So thank you once again. Thank you all the attendees who attended this program for today's program, and we'll be coming with more and more programs. Just stay tuned to our Easter Deakin chapter of Facebook page where we post all the upcoming programs there. Thank you, everyone. Thank you, our chapter president, Mr. Anangaru, and program chair, Mr. Vema, and all the Easter Deakin chapter team who made this program successful.